Okay, difference of squares is our final type of factoring. So I'd like you to write this down, please. A difference of squares is a binomial of the form, okay, it's of the form x plus 3 and x minus 3. And what this does when we FOIL it is gives us x times x, so x squared, x times negative 3, negative 3x, 3 times x, so a positive 3x, and then a 3 times a negative 3 gives us a negative 9. So when I combine like terms, what happens with my negative 3x and my positive 3x? They add together, but what happens when I add a negative and a positive of the same number? They cancel each other out, right? So this just becomes x squared minus 9, because those middle two numbers are the same but different signs, so they just get to be 0. They cancel each other out. So anytime you see this pattern, okay, this is a very important pattern. Anytime you see the pattern that looks like this, it is called a difference of squares. So again, it's a binomial, which means it's two parts. The front number has to be a perfect square. Perfect square numbers, remember, we already did a unit on that, are numbers that square root nicely, like 9, 16, 25, okay? It's called a difference of squares because there's going to be a subtraction sign. Difference means subtraction. And then the back term also has to be a perfect square. So whenever you have a perfect square, subtract another perfect square, you can use this pattern. Now the pattern that you factor it is right here, this pattern. So you square root the front, and you put it in the fronts, and you square root the back, and you put it in the back. Okay, and that would be the pattern that goes along with it. So let's try here example 3. We have 25 minus 36x squared. So the first thing you should ask yourself is if it fits the difference of squares pattern. So I look at the front part, and I say, okay, 25, that can be square rooted nicely. What's the square root of 25? 5. How about 36x squared? Is 36 a perfect square? Yes. What about x squared? Is that a nice square number? Yes, it is. So I have two squares with a subtract in the middle. That means it's a difference of squares. So all I have to do then is square root the front and put it in the front, square root the back and put it in the back, and then my signs have to be different. So again, it's a difference of squares, so your signs in your answer will be different. Okay? It does not matter if the plus sign goes first and the negative sign goes after, or vice versa. The signs just have to be different. So for the last example here, we have 5x to the power of 4 minus 80 y to the power of 4. So this is a big one. Let's see what we can do. Always start by removing the GCF. Is there a GCF that goes into both 5 and 80? 5, yes. So I'm going to divide these both by 5. So when I remove the 5, I'm left with x to the power of 4 minus 16 y to the power of 4. Okay, so now we're going to look at the part in the brackets. We removed the 5, we stuck it out front, so that should be okay. X to the power of 4, can that be square rooted nicely? Yeah. Yes, into x squared. How about 16? Can that be square rooted nicely? Yeah. Into 4. And how about y to the power of 4? Yeah. Into y squared. Okay, so I'm going to keep that 5 out front, and then I'm going to do the difference of squares because it's a subtracting sign between two perfect squares. So the square root of the front is going to go in the fronts. The square root of the back is going to go in the back. And then I have to put different signs. So what we should be recognizing here is that x squared minus 4y squared is actually a difference of squares again. So we're not quite done, but almost. So when I take that part and do the difference of squares with it again we take the square root of the front and put it in the fronts, the square root of the back and put it in the back, and we put different signs. At this point, there should be no more differences of squares that we can deal with or anything, so that would be considered fully factored. And that is pretty much as hard as these ones get, because that was a really difficult question. So for today's assignment, we're going to take a look in the textbook, but we're just going to look at numbers 10, 11, 12, and 13, and you can just choose any 3 letters from each of those questions.